in a library of mine called souffle-haskell. I've been optimizing it over the past few weeks, and it was mostly C++ code, so I don't think that it was that interesting. It was mostly figuring out segmentation faults. But now I also found a place where we can do an optimization on the Haskell side. So that's what this stream is going to be about. So let's get started. First, let's see if all the tests are green. Might take a little bit, but better to be sure about it in the beginning. While it's building the tests, let me check if my Twitch stream is up and running. I think so. Yep. Okay. So, meanwhile the tests, they just passed. So, what's the change I have in mind? So, yeah, this is probably going to be quite a lot of code all at once, but what I want to do is this library, it writes data to C++. Using a lot of different functions, like I have a variant for each basic data type that's supported, like int32, uint32, float, and so on. And also, you can get the data back from C++, and that's with these pop functions. But that's not the part we're going to focus on today. Today is going to be all about pushing from Haskell to C++, and it does a lot of low-level pointer manipulations, and it uses that to write all the Haskell values into one big byte array. And the optimization I have in mind is to reuse the byte array, and that saves you from having to reallocate data every time you send something over to Datalog or to C++. And here we have, no, not this one. Yeah, it's this handle. And what I think we need to do is we need to extend this handle. Right now it only takes a foreign pointer to a souffle program. But we will need to keep track of a byte array here and update it too. So we will probably need an mvar or something as well. And then we have various functions. So like find fact is one. It's the only. I thought add facts is also one, and add fact is the last one, I think. Yeah, because write bytes underneath the hood, it also uses estimate number of bytes, and that's a trick I do to go from the type level to a number of bytes, and we either know exactly upfront how many bytes it takes, or we have to estimate it. And both approaches, they work very differently. If you know exactly how many bytes you need, you can optimize it much more. But I want the approach to work for both ways. So yeah, and the way it happens is if you know exactly how many bytes you need, then you can use allocate bytes with a certain number of bytes, and then I have like a fast marshalling monad to use that pointer that you get and fill it along the way. And for the slow path, it's slightly differently, because here internally it manages the byte array itself, because sometimes it has to reallocate if it notices it does not have enough memory. So what I am planning to do is first write make the change for the fast path, and once that's properly working, then we can check and make sure that it also works for the slow path. So let's see. think we can also, whilst we're at it, we can unpack this. That should still, ooh. Yeah, I've been swapping a lot between MacBook and Linux, so my key bindings might be a little messed up. But this should still compile. Yeah. So we have that, and oh, I'm not sure if that works. Wait, let's skip the annotations for now, but I think I also need an mvar of like, yeah, how will we call it? Buff data, I guess. Oh, wait, let me. Yeah, still getting used to the Haskell language server shortcuts, but they're so amazing. So what we also need is we need like buffer data. I will probably figure out a better name later. And the buffer data that will probably have a pointer to something and a byte count. And let me see, do I already, oh, let me move those definitions up. So these types I already defined previously in my library. So let's see, yeah, we use byte counts, but what is this internal byte buff thing? If it's, oh, it comes from my bindings module. Ah, it's an empty data type. Okay, that's fine. So we can use, it doesn't really matter what type the pointer has, because it will be cast many times anyway. But usually you can use that for type safety, but not in this case. I think here we also want strictness annotation on this thing. Okay, and now we are already getting some errors. That's okay. Oh. For run we don't need it. Numtrans also not important. Here also. Let's first get it to compile. Okay, still an error somewhere. Oh, okay. It's probably complaining that this is not used. That's fine. But here, yeah, I think here it wants this thing is not fully applied anymore. So let's see. Let's move this to a separate line. How do we call this thing? Yeah, it's like a souffle handle. Yeah, this, I think we can get rid of one fmap and let me try this. No. Let's see. So this action that takes wait, hang on a minute. So if you look here, you see that souffle handle is already maybe a foreign pointer to the souffle program. So let's just, instead of trying to make it as short as possible, let's be a little bit more explicit. We can always refactor later. So if we have nothing, then we do action nothing, and like this. Let's handle this. Okay, now it wants the mvar. Still not happy. Oh, yeah, here we need just the handle. So we can probably refactor this later, like maybe do this. We can refactor that probably even further, but let's wait with that until we have it compiling. So now we need an mvar, so mbuff data, and yeah, now I need to open a browser because I am not familiar with mvars at all. Usually I try to stay away from this mutable stuff in Haskell, but there's a first time for everything, I guess. So we don't want an empty one, I think. Yeah, I need to think about that. What I think we need is we need to create buff data straight away. Well, we can always make like an empty buffer, I guess. So then we can always use this one, and with the other ones, yeah, I need to see which one is best. I think this will also be an important one with mvar. Oh, and there's also a masked one. Okay. Oh, and this. Ooh. Yeah, there's a lot of useful functions in there. New mvar. Okay, now we need a buff data of null pointer and 0, I think. We need lift.io. Okay. It's happy again. So let's run the tests, and in the meantime, let's see how we can refactor this. So I think what we can do is move this on one line. And then like this. Basically getting rid of one variable name and one level of indentation. Yeah, and now, this feels a lot like fmap. Let's see, let's go back one step. So we know we can do that. Let's go. I want to see the type signature for init. So if I do this, what is this type? That's an IO action. Okay. That's not what I wanted. So let's try the refactoring I mentioned earlier. So move action there. And does that work? No. I think I need to do. What? Expected type. Maybe. Actual type. No, that's not what I want. well, maybe we can just leave it like it was. I mean, like the refactoring we did just a second ago. But it feels a little bit like this is something that fmap does. So if we get nothing, let me copy it. Let's see. I think instead of, I think I can do this, but I don't know if I like this more than what I had. Oh. Yeah, let's leave it. It's fine. So it will be like this. Where is result coming from? Ah, right. Oh wait, that's not good. Okay, tests are still happy, so let's leave it like this. Okay, and now in this path, first let's copy it so that we can see the old code, and now here we get our buff data, and now let's see. So let's write down what we want to do. So get value out of mvar, and at the end store value back in mvar. I think this is automatically done with mvar. If the number of bytes is well, buff data is large enough, reuse buffer, else create new buffer, store that. Okay, and let's see which mvar function we need. So this function allows us to get the value outside of the mvar, and it does something with it. So I think we either need this one or this one, and this variant, it takes in, so this would mean this would be the buffer in our case, and we would have to return the new buffer at the end. But it always returns units. Don't know if that's possible, but the other variant, if we return a tuple here, then the second value is also the return value of the entire thing. And what does this do? Yeah, the value, this value needs to be returned in the end. Okay, so modify mvar masked and then buff data. Wait. Oh, let's make this do block to get a better message. Yeah. Okay. Let's call this buff, and then or buff var, yeah, bike chatting a lot, and then here we get the buff data, pure, and here we return a new buff data and the results. Okay, so we did this part, and also, yeah, okay, let's not remove that part, but yeah, do we have functions yet on this thing? No. So let's see. Buff size, I guess. Okay. Well, I could have just pattern matched on it as well. Anyway, if buff size, buff data. Okay, and then if that is larger than num bytes, then something else something. What's going on here? Yeah, it's complaining about a lot of things, but this is the case of find fact, so we only care about the size of one fact. So if the size is large enough, then we can reuse the buffer. So then I think we can do this line. Let me think. I think we can do directly this line. Let me write it out in full, and then we do this. Wait a minute. Pointer is let pointer is buff pointer of buff data. Okay, so if the buffer is large enough, reuse it, that's that. Otherwise, create a new buffer and store that in the mvar. Okay. And we might have to use a foreign pointer for this. Yeah, I'm pretty sure we will have to do that. But in this case, pure data found like that. And in this case, foreign. I already have this function somewhere. Malloc foreign pointer bytes. Okay. Okay, so we can just do allocate buff. So where's the code we were working on? Array allocates buff and then num bytes and then buff data byte array and then num bytes. So, well, actually I can just do this. No, I can't. Darn. Alright, that's fine. Why is it complaining? Okay. And now we have the new buff data. Oh, it's complaining here, but okay, let's fix that in a second. But now we can do the same part here as well, but here we need to do it like that. And let's remove this. It's complaining about a lot of stuff now. So, and here I think it's complaining that it's not a foreign pointer. So that's the next thing we have to fix. Before I forget. Okay, so let's see what part has an error now. This part. Okay, does foreign pointer have a null pointer kind of thing? Or maybe I should search for foreign pointer. Doesn't look like it. Oh, we have new foreign pointer. Yeah, okay. So maybe let's see. So pointer, new foreign pointer, and then it takes new pointer. Here we also have to do lift.io. And I'm not sure yet if this okay. I think it doesn't have a finalizer now. Because if it tries to clean up the null pointer, then bad things happen. And now I see 2 lift.ios here, which feels like a lot. Makes me wonder, can we just do this? So have 1 lift.io there. No, because this lift.io turns it into a souffle-m, but this lift.io, oh, there also. Okay. Let me rewrite this thing again. Yet another attempt. Okay, souffle handle of well, it's slightly different now because what's going on here? No. Maybe. But anyway, as I was saying, we are revisiting this function a lot, but yeah, it's being modified constantly as well. But yeah, I'm not happy with the shape of it, so yeah. So what I want is, I want to always apply the action, but this internal init, that returns an IO action, but this has to be souffle. Okay, now what if we put the action there? Okay, this is already better. And now can we put the lift IO here? Probably not. Okay, but then we can put it here, and then here it can be removed, and here also. Okay, now it's starting to get a little simpler, and now I'm starting to think this part can be refactored again as well, but now it's slightly different. Yeah, now this works. Okay, so the problem I had before was with this just that I had here. That was one layer too many, and that's, yeah, that works now. So, okay, that was like a really long refactoring, but it works now. And, okay, one final thing is this. There we go. But what we do now is we initialize the program. If we get nothing back, we return nothing. If we do find something, then we initialize a new foreign pointer, and then we use that to create an empty buffer. We create a new mvar that contains that buffer, and then we store it in the handle. And now we have 4 errors. Wow. I should get a shortcut to find the mistakes. Okay. This becomes with foreign pointer. I guess we can inline that part, but data. Oh, darn. So here we get the pointer now, and then we do this. And what's it complaining about now? Better. Okay. We can probably refactor this much more later. But first things first. So let's see. Here we also have to do with foreign pointer, data prime. Pointer do like that. Found. Okay. And we have some duplication going on. So what I think is better is, well, I think this part is mostly identical except for the actual buff data. So I think we can rewrite it. Oh, like this. So buff data prime. If the size is large enough, then buff data. Otherwise, this one. Okay. And what I think we can do now is get rid of all this. Let's get rid of that part. Okay. And we need this pure because of this allocate buff. A little unfortunate, but okay. Yeah. Okay, so if the buffer is large enough, then we return just the buffer. Otherwise, we allocate and we update the buffer and we store that. And with this new buff data, we can get the underlying pointer, marshal it to the other side, and check if it contains the fact. And then we, because this entire thing is running in modify mvar masked, that means that we here have to return the updated mvar and if we found it. Wow. So that we did that part and also that part. We still have an error somewhere. Wonder where. Here. What's going on here? Oh, and I thought we refactored it. No. OMG. What? Expected type IO, actual type souffle-m. What's going on here? No, I'm just guessing now. Let me rewrite this entire thing. I'm getting a little fed up with it. So what we want is souffle and results. That part is, that's fine. And then here we need to do lift IO because we need to get souffle m back. So now we are in IO. Yes. So we can say souffle handle and then this part. Oh. Okay, that's fine. Now, case. That's the part that I don't get. Why that doesn't work. Wait, let me try one final thing. forget it. Okay, souffle handle off, nothing, nothing, and otherwise just souffle handle on. It's a little bit disappointing. That's maybe something I will do when the stream is not running anymore. Is it happy now? No. Why is it not happy? Oh. Left IO. No. Oh, that's because this is an IO. Okay, what we can do is lift IO here and then point wait. Buff data. Here we need to do lift IO, then move this into there, then yeah, first really bad name and then pure buff data pointer 0. Wait. Okay. And this why is this complaining? Expected type IO. So I can't move the IO here, I need it here. Yeah, that's unfortunate. Anyway, let's go with this. And let's remove this entire part. Okay, it's happy now. Make tests. Wonder if it works. So compiled mode seems to work, but with the marshalling, yeah, it works. Yeah, I keep getting hung up on this function that does work the way I want it to, or that does look the way I want it to. So we were at find facts. So let's see if this is finished now. Well, it's not, because we did the fast path, but there's also a slow path. It's this one. But maybe let's get back to that one later. Another function we have that also has the fast path, that's this one, write bytes. Let's see. Yeah. So let me copy this part. We will have to do something similar to that, but we don't have the mvar here yet. So let's introduce it. So we get an mvar of buff data. Okay. And now we have a lot of errors. this here, bus bar. And it's happy again. Okay. So I think we can do the same trick here. Well, maybe we can even put it there. Let's see. I think we need to do this entire part in the same way. Oh, so. Oh, it's complaining somehow. Oh, that's probably because of the return type not matching up. Data prime and results. Do it like that. This part can be deleted. This also. So now we need to do this part. So with foreign pointer, def data prime. Get the pointer back. And now we can do. We have the pointer, so that's the same as this line. Oh, and I found the difference. Okay, but let's do this first. Push facts, what does that do? Push facts returns units. Okay, so that means that we can use the slightly more easy one. Get rid of this. Yeah. And wait, hang on a minute. So this line, we have that. So did that, and also did that. Okay, so that can all be deleted, but this line is important because the number, it's not just the number of bytes, it's the number of bytes times the object count. And then we also have to do that there. So let's total byte count is wait, yeah, we have to do it in here and not in the where here at the bottom because we don't have the number of bytes yet. We only know that because we pattern match here. So, okay. So where's num bytes used? Here. So this becomes total byte count. And here as well. Yeah. So like that, I guess. Let me double check. If you get this wrong, then you have the segmentation fault. So I have to watch out with that. Oh, and I also just noticed that I have the wrong title for the stream. Maybe it's not too late yet to change it, like halfway through. Let's see. My bad. Anyway, so we have this then. Okay, yeah, that should work. So let's try it. Make tests. Oh, interesting. Oh, yeah, we don't use allocate bytes anymore. Should be fine, I guess. Well, this part already works, and at the end I have like really thorough tests on the actual marshalling. Yeah, it's all good. Well, that's maybe a commit that I can do. Reuse byte arrays for fastpath Haskell C++. Not too bad. Okay. Now we will have to do more changes. So let's see. Slow m. So wait, before I go too fast, so if we know the exact number of bytes, then we can allocate once up front and that's it. Then we can just start filling the byte array and yeah, until we reach the very end, and then we can push it over to C++. But now here, in the other case, so if you have like strings that you want to send to Datalog, you don't know the exact size up front without having to go through it a second time. And that's why it's estimated. And if it's estimated, we sometimes have to reallocate. And let's see. So, and the way I solved it was you just give the number of bytes to this other monad. So it works totally differently compared to the fast version, because that one is so straightforward. Yeah, it's also much faster because of that. But the slow variant, yeah, you give it the number of bytes, and then internally it will manage yeah, the byte array itself. But there is a way, because in this do block we are in that monad, we can get the buffer out. So I'm thinking we need to add argument here to this function, or we need to pass in the mvar into that monad. So that we can then use that mvar and at the end get the final buff data back out. Does that make sense? Let me see. Yeah, let's just try some stuff. So right now the monad is basically state t over IO, which is really bad, I know, but it's fast, and that's what's important here. And it already has foreign pointer to a byte buffer or byte array. It has the raw pointer, and I did that so I don't have to use with foreign pointer each time. We have the offset into the byte array, and we have the total amount of bytes, or the byte count. And I'm thinking now, how can we make this work? So here we see that it allocates the buffer. And here it does some unsafe function to get the raw pointer out, and then we can build up the begin state and go from there. The offset is 0, and we know the byte count. And let me also see where it resizes, because that's also important. So yeah, at all the different serialized functions, it will call resize buff when needed. Then we get the state back out. We check, do we have enough size? If we don't, so if the total byte count plus the offset, which is like, the byte count in this case is the amount of bytes we want to write plus the offset that we are at. If that goes beyond the amount of bytes that we have, then it calculates the new amount of bytes that it needs for the byte array. It allocates the buffer, it copies everything over, and then it builds up the new state and stores it again. So yeah, so maybe let me move these functions next to each other, because I think I will have to do modifications in both of these, so it's handy if they're next to each other. And now, so let's see, this thing right now has a foreign pointer to byte buff, and where is that used? So it's okay. So each time we have a function where we serialize, at the end we find we get the final buffer back out. Okay, I think. Okay. So if we add this mvar here, let's see. Mvar of buff data. Okay. Now I want to go and see how oh yeah, that's going to give a big error. That's fine. Let's see. Yeah, we need that line. Wait, we need the entire if. Give it some space to see what we're doing. Let's see. So yeah, we need to do modify mvar masked. But that can give a problem. I think what we need to do is we don't give it an mvar, just the buff data itself. And here we keep track of the buff data instead of the buffer, because the buff data will have, that also has this foreign pointer thing. Yeah, okay, so let's try that. So buff data, I think this is double then, which yeah, I think that can be deleted. Let's find out. So let's see. This byte count thing, is that still important? How do we use it? Okay, so that's like the estimated byte count. Yes. Okay, so now indeed this line comes. So if the buffer size of the buff data is, and this is just byte count then. So if it's large enough, then we just use that. Otherwise, we allocate a bigger one. And okay. And now we don't do this part anymore. So as you can see now in this else branch, that's the only place we do the allocate. And previously we always did it. And now comes the nasty part. So buff pointer, I guess. And now here this, get rid of that, because that's stored inside the buff data. Let me think. So if this is large enough, then byte count will be much bigger. Is that bad? So if we do a resize, yeah. So it will always grow by powers of 2, but if the first time you have a byte array of 100 and then you want to write 110 bytes, then it will double it to 200, and I think before it would go to 220 or something, but I don't think that's a problem. Anyway, I think that function is fine. So the buff data is now in the state, and we will have to get it back out at the end. So let's do, this has to be removed, and we have to say let total byte count equals buff size buff. Is that happy again? This can't work yet. But let's first fix the other error, probably at the bottom. No. Here it is. Yeah, I guess this is similar. So let this buff size buff, and then what is going on here? Oh, nice. Wait. Oh, it was not modified before. Okay, then you can just remove it and it will work. And now we get 10 errors. Yeah. Okay, now it's also failing at the previous one. Interesting. Buff. Okay, that's buff data. That's an easy one. Here we need to do the prime thing. And here, what is going on here? So here we need to get buff pointer to the buff, because previously that was a raw foreign, well, not a raw foreign pointer. It was a foreign pointer, and now it's like a data structure holding the foreign pointer. So we copy over the buffer from the old one to the new one. And then here it's probably also complaining about new buff. Wait, first that needs to go. Now it complains about this. Yeah. I guess we can call, yeah, let's call it buff data to make it more obvious. I also need to refactor that is buff data of new buff and new total byte count, like that. And this part I want to rename to buff data now. Oh, wrong shortcuts. Yeah, I think that makes sense. Still 6 errors. Oh, yeah, that makes sense. So this is because we don't pass in the mvar yet, or the buff data actually. So modify mvar masked. Yes, that one. So here we get buff data. here we need to, let's see. I think like that, but what's going on here? Oh, do here? Okay. So here we need to do buff pointer of buff, and let's call this buff data. Yeah, I need to do a lot of renaming. I think, oh. What? Oh, and now here, I think we also have to pass it in, no? Wait. First the buff data and then the int. That's a lot of red. Let's restart. So we need to return some buff data and found at the end. Buff data prime something found something else. Is it happy about this? No. No, still not happy. Why? What am I doing wrong? What am I doing wrong? Let's save it, and I want to see the compile error. Oh, many errors. Okay, that's further down. Oh, of course. Here we have to pass in the buff variable. Aha, that's better. And I think if I remove all this and comment it, what is it saying now? Expected. Oh, that's probably because of this stuff. No. Wait. I'm going too fast again. Let's see. What's the signature? So it takes the monads. Ah, okay. We might have to change that to make it easier to use. C like that, and it's happy now. So the buff data goes in here, and the one we get back here is not necessarily the same. And then we check the underlying pointer. Oh yeah, that's the start of the buffer. And then we give that, we use that to send the data over to the other side. Yeah. And then we return that. Okay, that's that part. We have 3 errors remaining. So where's the rest? Here it is, and we can remove this part also now. And here we have to give it the buff variable. No. Here we have to do modify env masks, buff data. Like that, no. Oh, we have to No, still not happy. Why is it not happy? Okay, it's compiling, but it would surprise me if this works. And we still have to do a lot of renaming because and refactoring. I wonder. That would be kind of funny. It would be an easier change than oh. And it broke. That's not good. So it's not easier. Let's see. Let's rename that before I forget. No, like that. I was saying earlier that I wasn't sure if that would work as I would expect it to. Which place was that? But yeah, let's go back to the beginning. Slow. So, first of all, this thing it takes the buff data structure now, the Marshall state, and we start with a buff data. If the size is large enough, then we leave it unchanged. Okay. And otherwise we allocate. And we return the updated buff data. So, and then this gets stored in this variable. We use that unsafe foreign pointer to pointer to get the raw pointer out. And we build up the initial state. That seems right, except for this part. What if the size is larger, is that bad? Let me see, how does it... yeah, here it only uses the object count and it uses that to know how many facts it needs to read in the loop on the C++ side. So and all the rest is written to the byte array, so that should be fine. We don't use the buff size anywhere, but because previously we were looking at just the pointer here, and now we have to get the pointer out at the end. Yeah, and if all else fails, I can always do like print debugging. would be kind of crappy, but oh well. Let's see. So I think the run function is fine, but then the resize function. So the total byte count, yeah, this is a little different because it's now stored inside the buff data, but that's fine. The check is the same. This calculation is also the same. Yeah. Then we need to allocate a buffer of the new size, copy everything over, and then we need to get the new pointer back out. build the new buff data. Let's see. Yeah. The offset makes me think. Yeah, we need the offset. Yeah, I was thinking, why is the offset added here but also kept track of? But you need that for a copy, and it was working like that before. So that also seems fine. And here we update the same way because the byte count is now inside the buffer data structure. Yeah, and all that code does not care about the buffer size. No. That's all the same. Here we have some changes. So here, which test did it fail? Oh. Doesn't say anything. That's nice. Might be related to the null pointer thing that I was doing it at the start. Let's see. So here we call our run function, and then we push our fact into the byte array. Then we get the internal buffer back out. Yeah, that makes sense. And this should be the final buffer because all of the resizes update the buff data. Then we get the pointer out. Then we unwrap the foreign pointer to the raw pointer and use that to send the data over to C++. So that should be fine. Okay, let's try something here. So let's go to compile spec and find fact. Is there a really simple test here? Yeah, I think the top one is the simplest. It will probably still crash, but then we can focus it on the error a little bit more. Let's see what's inside here. Oh, we need show. Wonder how it prints it out. Do we get to see an actual pointer address, or I don't know. We get nothing. So either it doesn't even get there. Let's see, what does the test do? So it calls run souffle, okay. Calls run and then find fact. So does that work? Wait, what? Oh. No. Let me use the fancy way. Wow. Okay, it prints the 1, and it probably doesn't print a second. Okay, that's okay. So it definitely goes wrong in find fact. So we can remove this one now. Go back here and now find fact. Let's see, where can it go wrong? So it goes wrong in the slow path. So let's see, lift IO. Yeah, this is super bad, and normally I don't do this, but if with a segmentation fault, it's like you're completely blind. So yeah, it doesn't even get there. So let's run that. I think it will already break after one, or maybe even before that. We'll see. And that might mean that it has to do with the pointer. It probably does, because if it tries to copy over from a null pointer, yeah, that's bad. So it printed out 1, okay, and then it wants to push the fact, but that contains a string. Okay, so let's leave this garbage code for now. Where is that part? Null pointer. Yeah, this part needs to change now. Let's say we had a function for this, right? Allocate buff. Give it a byte count and get foreign pointer back. So allocate buff and let's allocate 4 bytes because that's the, well, actually I can say RAM domain size. No, let's do 4, just 4 directly. And yeah, that's a lot of information at once, but 4 is because it's either going to be something like an int or a float, that's always 4 bytes, that's the RAM domain size, or it's going to be a string, and those are always prefixed with 4 bytes, so then it will always work. But that also... Let's see, so then I think... Well, let's first run this. And if, yeah, what I want to do is I want to go back to the null pointer thing again, but it makes me think that it's in the Marshall slope, that it's going wrong here. But we're not copying. We'll see. Okay. Oh, we get to see an actual pointer now. Of size 72. Let's see, so let's go back so we know a fix for it. Oh, that was strange. Wait. I was allocating a buffer of size 4 but storing length 0. Okay, so it really has to do with the null pointer stuff. Yeah, okay, resize when needed. Let's see. Well, we want to keep this as fast as possible, so if we can use a cheesy trick like above, then maybe we should just do that. Let's see. Lift IO, print total byte count. So I think we will see size is. So I think we will see that the size is 0 in the beginning, and maybe we should just write an if there or something. Or we can try to be more clever. Oh, that's That's interesting. So it's immediately set that the size is 72. Okay, why is that? So if the size is large enough, then that. Otherwise, do this. Let me print out the buff data here as well. Also kind of interesting that we saw it twice, so it was resizing twice. Let's see, byte count, offset, total byte count. We're close. Okay, so what's it saying? So 2 times, it's the same pointer. Wait, and then 5072. So what's that all about? So 5 is the byte count, then the offset is 0, and then the total byte count 72. But it's not a null pointer. What is going on? I still don't understand why not using the null pointer works. That's so strange. Is it because it drops it somewhere at the end and then calls free on it? That's probably it. But that makes me just think, don't we... where did we do the null pointer thing? What do I do on the C++ side? I think I had similar stuff there. So sorry guys, some C++ coming now. So here it knows the size. No. So wait, serialize slow. Then it goes to the serializer struct. And the number of bytes is 4 plus the fact count times the tuple size. If it doesn't fit here, we resize. Oh. Yeah, this node might be important. So, okay. Let's try another thing. Because this was not a problem before. So it's in the slow function. Let's see. Let's see. if the size is large enough. Yeah. Let's do some more printf debugging. So I think it will break here. Yeah, this feels a little bad, but that's what you get for segmentation faults. Yeah, okay. So we are on the exact line where it breaks. So let's see what everything is. New buff. Buff pointer to buff. Or let's just print the entire buff data. And what's the total byte count? And that's the old size of the buff data. That should be the same. Wait, what? Oh, we still have to print one. Oh no. Darn. Let's get rid of this. Now it's getting in the way. So it does push. Okay, well, we can put some logging there as well. What does this write as bytes do? It gets the pointer. Wait, no, that's the fast one. We need the slow one. Here it is. And we are writing strings. So we'll call push text 2 times. And let's put some logging here. Print 1, print 2, 3. Okay. So this is the part where you really miss the high level Haskell. But in general, even the low level is fine. It's just when you run into this, then it gets a little ugly. So 1, 2, and then it writes beyond. So it prints 2 and then it dies. So poke writes to the byte array, so it probably writes beyond what it's allowed to write. That's interesting. So let's see, let's keep that tree there, and then s get, and then print s. Here we go. Yeah, so somehow it tries to write. Oh. Did we forget to update the pointer somewhere? Because yeah, if it tries to write to the null pointer, then it will break. Yeah. Okay, so we know why it's broken. Are we forgetting to update the state somewhere? Yeah. So let's see. Increment pointer, that just increments it. That's fine. Where do we do a put? That's the fast one. That's not that interesting. That's also the fast path. Resize buffer when needed. So do we arrive? Don't think we do, but let's run it. And in the meantime, continue searching. So it's probably going to be a statement like this where I forget to update it. Oh, that's bad. Yep, that's bad. Shame on me. But yeah, even like before, how did that work? So what went wrong was it was writing to the wrong. Well, we were computing. If the size is not large enough, then, or if it is large enough, then we just use the original one, and otherwise allocate a new one. But then we still need to get the pointer from the buff data. But I was using the wrong one. So now. Yes, now it works. And it's also not a null pointer anymore. So let's get rid of the ugly print statements. Huh. It wasn't even resizing. Okay. I was planning to finish this by 10 p.m. and it's exactly 10 p.m. now. It's kind of funny how that works. So I really hope that was the final mistake. But we'll see. Come on. It's not crashing yet. And if that works, then I will have to do that off stream. Ah, nice. The next thing I will have to do is benchmark all this. But yeah, I can't do that on stream because streaming uses quite a bit of CPU. Let's get rid of those show statements. Yeah, and the renames and stuff, I will do that off camera. Get rid of that. So, no. Let's see. So here we combined the foreign pointer and the byte count into the buff data. That's actually a nice refactor. And then we had these two functions that were rewritten to manage the buff data. Yes. Yeah, this looks good. Yeah, that block was moved up. Yeah, here the total byte count is gone. That's inside the buffer now. Yeah, I need to check if the modify mvar mask stuff, what it means if the block is too large. If I need to take performance into account, but that's where the benchmarking comes in. that is basically the same change but in a different place. Yeah, and that's it. Yeah, okay. So, what was my last commit? Reuse byte arrays for slow path Haskell to C++. Actually, quite a small change, but yeah, the searching always takes a while with these things. So yeah, I guess that's it for this stream. So thank you all for watching, and see you next time. Bye.